Hello, hi. It's been a while. I'm waiting for my Zoom camera, and after which you will see interviews from me. All mostly techie in the beginning, all technical, like chemical engineers, doctors, and math professors. There are three lined up, and after which, after the interview, which is going to be friendly, not out to prove that I'm smarter or or anything of the sort. They are gods because they're working for paychecks. So I'm going to interview them, and then but that comes after. So this is a study. Interview them, and afterwards, give an overview of my own and a thought of my own for their papers. All right, but that comes after. I'm waiting eagerly for my Zoom camera. Have been asked not to do anything in the arts. So now this study, my MN project, my MN thesis dealt with L-DOPA production using immobilized tyrosinase. Tyrosinase, as you all know, is an enzyme, and it involved adding L-tyrosine, an amino acid, L-tyrosine, an amino acid, uh, to ascorbate, which is vitamin C. So where I have vitamin C here as well. Vitamin C. Oh my God. Oh, what happened? Oh, so this is here. I'm going flowers. I think I have the god of this is my fall. Uh, uh, Vitamin C. This is an immune booster actually. So vitamin C, that's ascorbate. Ascorbate prevents all these reactions when added because this tyrosine to L-DOPA, and L-DOPA is a drug for is passes the blood-brain barrier and converts it to dopamine, the neurotransmitter which is uh, lacking in people with Parkinson's disease. There's some problem in the brain, so not enough dopamine is being made. So it has symptoms, etc. You can look it all up. Just for effect, I'll show you a picture of the brain because L-DOPA and healthy brain means making it work here and there, or if you're not techie, that's all. I think techies have to make it work. Oh, this is this is a picture of a brain, and this thesis is in the reading room in the Department of Chemical Engineering um, at the University of Toronto. My MASc thesis is on the internet, and there's a twist in this experiment. I'm going to use a metallic um, catalyst, inorganic. Well, picolinate is organic. I think if I remember correctly, I have studies with it, which are like research papers, and it has a benzene ring to it. I think the aromatic ring. So, but I would have to check though. But this is the catalyst. So it's an inorganic metallic catalyst, chromium picolinate. Um, or is it an organic? Well, maybe I need to look up. All right. So chromium picolinate, or it's not relevant to the study. I'll let you have the fun yourself. This is a micropipette. All right. This is my makeshift micropipette. It's an ice cube tray, and in Iron Corporation, I worked with this, and it struck me that this is a very nice way this afternoon of doing kinetics. See, and I'll be studying first order and second order reactions. And Levenspiel says if A forming products is a first order reaction, 2A forming products is a second order reaction. So I had third order reaction also planned, and I have space on the ice tray or my makeshift micropipette tray. But I have only so many tyrosine capsules. So in a lab, it would be very difficult. You would have to make buffer, arrange for, I have 10 little reactant vessels, which I'll stir in there. But then there we would have to have stirrer heaters, etc. And it's a lot of work, but simultaneous studies are encouraged because you collect a lot of data, and so at least we're encouraged by my supervisor. Brad Simmons, whom I am fond of saying has become a bit of a Dr. Jekyll and Mr. Hyde sort of a scenario there. All right, so all these compartments, sections of the micropipette tray have 30 ml of water. So pH 7. My study was run actually at 6.8, but that was the optimal pH for tyrosinase. There's more to it. Even I don't remember the exact specifications of my study. I think that there was a slightly acidic pH was used. The optimal pH it's always written on the box of the enzyme. So this is chromium picolinate. This is my enzyme. This is my metallic enzyme and tyrosinase. So this is easy. All right. So I'm going to get my so to stay with me here. So first order and second order. So first order. 3 minutes after, I'm going to be adding the second one. So it occurred to me because we did this in Asian Corporation. So it would be a neat time study. Because we are adding the enzyme or the catalyst here, but back in Asian Corporation, another female who was hired with me, feminist female, who she had a PhD in chemistry, fresh graduate from McGill University. Catherine, she and I did this, and the beauty of the study occurred to me this afternoon is that if you add 3 minutes past the sampling, so addition times being 3 minutes after, then you have a neat reaction. If you introduce that enzyme every single time 3 minutes after, or the catalyst 3 minutes after, then you have a study. Oh, would that be right? 3 minutes after. Continuous study. Your sampling time would also be after. So I think it would be a neat time concentration profile study. We will know. All right, because I'm going to test it out. If it's right, my thinking is right. All right, so I'm going to get all this as well. So we will do one first order reaction. First order reaction. There's only one first order reaction. Maybe 30 ml was a bit much, right? It's a little full stir. Second order reaction. All right, it didn't take a long time. So now I'm going to, I think I'm going to be doing this in a pentaplate. Okay, so this. And I'll be weighing an exact same volume. Density is the study, so density of a mixture, etc. Okay. We actually didn't mix it then, so I'm going to add a teaspoon of vitamin C into each. Vitamin C is ascorbic acid. All right, I don't need a spoon here because this has a spoon. So this is once it's all done. So beginning here. Okay, half a teaspoon is enough. This is just to prevent the back reaction, the continuous subsequent degradation of. All right. Micropipettes are hard. I think I took 30 ml was not right. We were asked to take less. It's an immune booster, actually, vitamin C. Okay. I'm not consistent. All right, in our but then this is not an enzyme kinetic study, and it's not a reactant. It's not A plus B, so it's not reacting at all. We will see. This is what happens with enzymes, but who knows? Chromium picolinate? No, it's an enzyme, metallic enzyme. All right, so I'm going to be starting first order reaction. First order reaction. First order reaction. All right, wait a minute. I used to leave it overnight for it to stir well and mix well. Second order, or I'll do first order reaction first. Uh, all right. There was no temperature involved. All right, it was room temperature, so 25 degrees centigrade at this time. All right, reaction started. Not yet. Enzyme has to be added. Metallic enzyme. Vitamin C does not mix, stir, stir. So this is all, food engineering. So all right, I'm going to add the enzyme. So enzyme is going to be constant. All right, so sorry. I've worked with enzymes, catalyst, metallic catalyst, chromium picolinate. It's going to be the same for both the first order and second order reaction. All right, so one enzyme. First order reaction, first order reaction, first order reaction. All right. Maybe that may not be right. But in Iogen, it would have been right. I don't remember the details of the experiment completely. So, it would have been a nice time concentration each. Which is this? This is the tyrosine. Capsules, have semi-permeable membranes or permeable membranes. So they go, that's why. So I'm going to start the timer. We will run the experiment for 10 minutes to 15 minutes only. 15 minutes only. Every 3 minutes, I'm going to take a sample. So actually, on the internet, the micropipette tray, which is available in the market, has a bottom which kind of merges all the concentrations. That's what it said. The micropipette tray which we use in Iogen Corporation didn't merge the concentrations. All right, so this is all going to fall down. I'm going to slip. Stir, 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 stir. So optimal enzyme concentration. So I keep saying enzyme again. Optimal catalyst concentration, metallic catalyst. All right. T equals 0. I have the labeling. So that should be enough. T equals 0. There's no L-DOPA. So I'm going to write down the mixing, it's reacting. So 3 minutes. 3 minutes, okay. So I'm gonna take clock. 3 minutes. So this is, oh my god. This is for first order reaction. 1 teaspoon and 1 teaspoon. Oh, this is okay. Okay. So this is about 25 by 10. So 25 grams by 3 minutes. First order reaction, second order reaction. 25 by 10. Okay. This is more. Almost 25 by 5. Alright, so next. We'll put this one. I've taken the let's check this out. Stir. See, oh my god, this is running fast. Okay. This is close to 25 by 10, 3/4. For the it's just 25 by 5. But then the teaspoon is coming down. Second order reaction. Okay. This went up 25 by 5. 25 by 5. 25 by 10. Yeah, 25 by 10. This is 25 by 5. Oh, this is okay. So some more stirring. Always stirring is key. I did so much stirring that I made it seeing undocumented reaction. You should look on my LinkedIn webpage. Six minutes. Reversible reaction. It's 25 by 10. Little less than 25 by 5. My one from the. It's almost approximately 25 by 5. You see, I'm reducing all this by a teaspoon. So my reactant, okay, reactant, I think I took a point a little too soon. 3, 6. Fifteen, 12, 9, 6. Next point, I will take it 0. So 15 minutes. Or inhibition is setting in. So it's this time. 4 minutes. 4 minutes. You could try it out. Fun experiment. Three minutes. Take a reading at 3 minutes. The last reading from the last that's 0. So I have both. Either by kinetic study, my instinct was right. In ions incorporation, it was right. But here, maybe not. So I'll do 2 readings. Okay, this is 3. Let me just take that. That's 1. That became 1. This was sorry, tray 1. So this is as 25 by 5, and this is 25 by 5. So see, even in this, it's like an enzyme. The reverse reaction is setting in. But further, it's not going to melanin and dopacone and etc. But it's becoming it's going back to tyrosine, I think. Once the timer runs, Stir, stir, stir. Stir up a reaction. Stir up a reaction. Made something. So the reverse reaction, as I showed you in my picture, is possible. So ascorbate immobilized enzyme, maybe it's certain. It's a reversible reaction, tyrosine to L-DOPA, L-tyrosine to L-DOPA. So T equals 0. It's close to so 1. Reaction on 1. This is 25 by 5. That equals 0, almost 0. This has dropped to, it's 100 grams. 100 gram marker. If I 100 by 10, 100 by 10, 100, 100, 100, 100, 100, 100, 100. Okay, this is close to, so 1/3 of 25. This is what it is. Okay. So I made quite a bit. All right. So we're going to look at one calculation or all the calculations. Okay. 100 by 10. So I began with, this is on packaging, 500 milligrams. Each capsule is 500 milligrams. Okay. Each capsule is 500 milligrams. Each capsule is 500 milligrams. Each capsule is equal to, we began with T equals 0, 500 milligrams and 1000 milligrams, twice, right? Second order reaction, so 1000 reaction. So I made at 3 minutes, so T equals 3 minutes, T equals 6 minutes, T equals 9 minutes, T equals 12 minutes, and then T equals 15. I took an extra, so T equals, here, 1, 2, 3, 4, 5. Took an extra, so somewhere in between, I have an extra point. T equals 0, T equals 3 minutes, so 10. But I have chromium picolinate and ascorbate. So these are also 10, 100 by 10, 10 grams. 25 by 5, 5 grams, 100 by 10, 10, 3, 4, 7.5 grams, 100 by 25 by 5, 5 grams. Oh, first order reaction is running really well. 10 grams. And so you would have to break it down, density of a mixture. So that's all on the internet. So I would be considering chromium picolinate, balancing the equation, and then considering this. So 100 by 10, I got the same thing. 100 by 100 by 5 is 20 grams. 100 by 5, 20 grams. Actually, the second order reaction is slowly progressing to a 100 by 5, 20 grams. 200 by 5 is what? 40 grams. 25 by 5, 5 grams. 1/3 by 25 by 3. Okay, so these are my points. So I have to look at the density of the mixture, and then next time, when the next time I'll show you which I'll discuss which is better. But I'd have to have the interview on, so the person will be waiting for me. The person at the person at the other end. So I'm going to discuss it after the interview. All right, after my enter on the paper, on the person's paper. So shall I say who's going to come? I have to request them. All right. So of the three people. All right. Two of them are my good friends, James C. Warrington, and he's I have to say his name because I will be introducing him. But they all get a lot of spam. So no spam, please. I beg of you, no spam. So James E. Warrington, he has a PhD in chemical engineering, has an MD. I have to ask him. So I have 3 published papers, and my thesis is in the National Library and Archives of Canada. So the president, I have to ask the president of London General Hospital, and then Professor David Dubbins. Another friend, he's a chemical engineer with a master's and PhD in pharmacy, and he's a professor in the University of Toronto for pharmacy, and I'll be interviewing them, then discussing their papers. All right, something, throw me a bone here. And then lastly, Professor Truss, his daughter's fame precedes him. She was the Prime Minister of Britain for a short-lived fame, but nevertheless, she was the Prime Minister of Britain for a month. In that month, introduced groundbreaking, must have some important work. And then her father is a mathematics professor, Professor Truss, and he's at this time in the University of Leeds. So some paper of his, has, for a hobby, you should take Professor Truss's papers. They are all so complicated mathematics. And after I've yet look at my friend's papers. But anyways, all complicated mathematics, Boolean, algebra, etc. I will come out with a chemical engineering aside myself, but first I'll interview him. All right. They all have to grant me permission, etc. My camera is being checked out, my Zoom camera, and that sort of thing. All right. Thank you so much. Next time, kinetics of the study. All right. As a test, first order reactions are better. What's the kinetic constant? Second order reactions are better. What's the kinetic constant? All right. Thank you. Signing off. Gayatri B. Sitaram.